Actually, this T-shirt here is capturing CO2, and then I will explain how. So my name is Patrick Tessonner. I'm one of the co-founders and the CEO of Xinterra. We are based in Singapore, and at Xinterra, we are on a mission to rapidly innovate new materials for sustainability by powering AI with high throughput experimentation customized for specific problem statements. The current materials R&D process is very slow, expensive, and limited. Also, the materials that we use in our day-to-day, they work, they do their job. However, they are suboptimal in terms of performance, cost, and especially sustainability. And to solve this problem, we created our platform XDF, or Xinterra Design Factory. XDF uniquely combines AI systems with high-throughput experimentation tools and deep domain knowledge material science that we have with our team to speed up the materials R&D by at least 10 times. Our business model is to use our XDF platform to create our own materials IP, and then we'll be monetizing on the materials IP. We can use this IP, we can license this IP to other companies that will manufacture and commercialize these materials. And in some cases, we can, to catalyze the process, the licensing process, we can use ourselves to manufacture and commercialize the materials, which is the case that we are adopting for now with COzTERRA. So COzTERRA is the first materials IP that we created. I'll talk more about it. And in the long term, so our vision is, we named our vision 100 in 10. So this means that we will be using our XDF platform to create 100 materials or formulations of materials in the next 10 years. The company that inspires us is ARM, ARM, so the company that developed technologies and architectures for chips. So they don't manufacture, they don't sell materials, they develop technology and they build over time a massive and successful revenue stream from licensing. And this is why we want to become the arm of the materials for sustainability, and we're starting with COzTERRA. So what is COzTERRA? COzTERRA is a carbon capture formulation that we developed to textiles, to be applied in textiles. And we're starting with textiles because we want to empower every human being on the surface of our planet to become a carbon capture agent. You see here in this video, you see two acrylic boxes. The one in the left has a textile treated with COzTERRA, and the one in the right, it's a conventional textile untreated with COzTERRA. And inside these boxes, we have these sensors. They are measuring the amount of CO2 in parts per million, in ppm. You see here on the left, the number is coming down. This is because the textiles treated with COzTERRA is absorbing CO2. This is exactly what this T-shirt is doing now. And in the other box, it's a conventional textiles. They don't capture CO2, so that nothing changes with these numbers. This is an accelerated video of a 6 hours recording, and this is the graphic representation of what happens during this experiment in terms of the amount of CO2 captured. This is another video where we compare, so it's very common, people ask us, how does this compare to a tree? So the same setup, we have a mini T-shirt treated with COzTERRA and a bonsai tree, a small bonsai, so we compare the same sensors. This is a shorter video, it's a time lapse of a 40 minutes video. In this 40 minutes video, both the mini T-shirt and the bonsai, they capture the same amount of CO2. This is because the message that we convey here is we want to work hand in hand with nature, not replace nature. We want to double down the CO2 absorption effect of nature. So what is exactly this product? So COzTERRA is a liquid formulation, so it's a formulation in the liquid form. We designed this product to be drop-in into the manufacturing, the textiles manufacturing stage We are an early stage startup, so we have a very pragmatic approach. We want to commercialize our materials as fast as possible. So to remove friction from this process, we came up with a formulation that can be easily applied in the existing equipment that the textiles mills use, and also that could be easily used by us consumers. So that's why we developed this formulation to be applied in the finishing stage of the textiles manufacture. The current version of the formulation is optimized for cellulosic fabrics, including cotton, and we already have promising results on wool, polyester, polyamide, and blends of these fibers. Currently, 20 people wearing exactly these t-shirts at the same time, they can capture the same amount of CO2 that a mature tree captures in a day. And in the life cycle of the t-shirts, these range from 16 to 41 grams of CO2, because it depends on how many times the t-shirt, the product is wear, and the weight and a few other properties as well. So one question that probably you may have is, what happens with the CO2 after it's captured? So it's very important that the CO2 so the CO2 cannot be released back to the environment. So we develop a process that, a mechanism that on the washing process, on the washing process of the textiles in contact with detergent, the CO2 reacts and becomes a mineral. This mineral is baking soda, sodium bicarbonate, which is a harmless mineral, can be that it's washed away, harmless to the environment, to us human beings, and after the wash process, it goes away. In the same washing process, the carbon removal, the carbon capture agents, they are recharged, so the textiles is ready to keep capturing CO2 all over again. And yeah, so this is how the specific mechanism that we developed to textiles to maximize the use of textiles on this carbon capture functionality. So how we have been using AI and high throughput experimentation to come up with this COzTERRA product. So our belief is that the AI is as good as the data used to train it. So that's why since the beginning of our company, our vision was we want to use to train our AI with high-quality experimental data that we can generate fast and with low CapEx and low OpEx. That's why we have this capability in-house to create our own tools or to adapt tools that we buy from the market. Since the main property to be measured here is carbon absorption, CO2 absorption, we developed these high-throughput environmental chambers. They are unique in the world. Basically, this is, you can see here 8 cartridges. In these cartridges, we put the materials that we want the performance to be evaluated. We pump a combination of gases, including CO2, of course, and we have a lot of sensors that they are measuring how fast and how much of CO2 is being captured. So with these two, we started building our library, our database of carbon capture materials, and with this library, we started training our AI, and then our AI, of course, I'm simplifying a lot the process, and after some time, the AI started recommending new formulations or combinations of these materials that could be adopted. And then we got 120 of these recommendations, 90 of these recommendations. We didn't find any prior art. And so we run these cycles several times. The more we run these cycles, the more powerful our AI becomes, and even better materials start recommending. And the most promising, we started adding 2 pieces of fabrics and then analyzing, using the same equipment to analyze the CO2 absorption with the fabrics with some of these materials incorporated. From ground zero, which is, ground zero for us is we didn't have any data and we didn't have these 2 to measure the CO2 absorption, to filing the patent application for COzTERRA in August of last year, we took 11 months, so which is very fast compared to the 3 to 5 years, most likely 5 years that established industries would have taken. These are examples of the curves, the data that we generate using our tools. So we are, in the stage that we are, we went to TRL 1, so before we didn't have any data, to TRL 8 in 14 months. So I mentioned that we took 11 months to go from ground zero to filing the patent, and then an additional 3 months to go from the lab to run the first industrial trial. So you can see the photos on the right. They show typical finishing equipment that the textiles mills they have. And this, as I mentioned, we develop our formulations to be dropping to this process. So 14 months from ground zero to running the first successful industrial trials in these finishing machines. Last year, Vogue and BMW, they organized the Vogue Innovation Prize. The Vogue BMW Innovation Prize, they selected 40 startups all over the world, very competitive process. And we were happy to be the winners of this initiative. So that's it. This is Xinterra. Please let me know if you have any questions. The WeChat contact, Shisha.
Wait, okay. 好，感谢Patrick. Anyone has any questions for Patrick? Okay.
So if we buy a T-shirt made of this, like how many cycles of washing can this effect last, and how many grams of CO2 would we contribute to capturing, like in the life of the T-shirt?
So currently in our lab, we tested up to 20 washes. So after the 20 wash, it still depends on the composition of the textiles, the fibers, and the weight of the T-shirt. But it goes, we tested, so up to 20 washes. After the 20th wash, it still captures 50% of the initial amount captured before the first wash. This can go up to 40 grams. So just for one T-shirt may not sound too much, but if you think about Manhattan, New York, so if the whole population of Manhattan uses these T-shirts, so they will be capturing the same amount of CO2 equivalent of 4 Central Parks. So that's why our tagline is individual action, collective impact, because just one T-shirt is not going to make too much, but if you have billions of people using, definitely will move the needle.
Thank you.
How do we buy one? Like where do we buy that T-shirt?
As soon as it becomes commercially available, so we are discussing with the first brands, then I'll let you know. Thank you.
Fantastic. Wow, what a great innovation.